Okay, so this time our topic. So right after statement of the problem, this will be the time for us to develop our hypothesis. So most commonly, if we had questions no about significant difference and significant relationship, most probably we could able to test in the hypothesis. Now, a research hypothesis or a scientific hypothesis is a statement about unexpected relationship between variables or explanation of an occurrence that is clear, specific, and stable. So when you write up hypothesis for your dissertation or thesis, make sure that they meet all these criteria. So if you do, you'll not only have rock solid hypothesis, but you'll also ensure a clear focus for your entire research project. So to give us more details about the topic, let us all welcome to introduce the null hypothesis and alternative hypothesis. Go ahead, ma'am.
So good afternoon, everyone. I am Jenna Celestino, and in the next topic, I will explain to you what hypotheses are and how to calculate a hypothesis test. So let's start with the general definition of hypothesis. According to Cambridge Dictionary, hypothesis is an idea or an explanation for something that is based on known facts but has not yet been proved. In other words, it is a statement that provides an explanation for how or why something works, based on facts, but has not yet been specifically tested. So this is the general definition of hypothesis. But in research or dissertation, a research hypothesis is a statement about the expected outcome of a study. And to constitute a quality hypothesis, the statement needs to have three attributes, which is this: it must be specific, it should have clarity, and it should be testable. A good research hypothesis needs to be extremely clear and articulate about both what is being assessed, which is who or what variables are involved, and the expected outcome. For example, a difference between groups or relationship between variables. For example, students who sleep at least 8 hours per night will on average achieve higher grades in standardized tests than students who sleep less than 8 hours a night. As you can see, the statement is very specific as it identifies the variables involved, which is the sleep hours and test grades, the parties involved, which is two groups of students, as well as the predicted relationship type, a positive relationship. So in here, there is no ambiguity or uncertainty about who or what is involved in statement, and the expected outcome is clear. A statement must be testable to qualify as research hypothesis. In other words, there needs to be a way to prove or disprove the statement. If it is not testable, it is not a hypothesis. Simple as that. So for example, let's consider the hypothesis we have discussed earlier. So with this statement, we could test this hypothesis by undertaking a quantitative study involving two groups of students, one that gets 8 or more hours of sleep per night for a fixed period and one that gets less. So we could then compare the standardized test result for both groups to see if there is a statistically significant difference. So remember that if you cannot test it, it is not a hypothesis. So based on the definition given earlier, a hypothesis is an assumption about an expected association. So for example, men earn more than women in the same job in Philippines. So your target now is to either reject or retain this hypothesis. You can check whether you reject or maintain your hypothesis by using existing data. Therefore, in order to test your hypothesis, you will conduct a survey among 1,000 employed people in Philippines. And then finally, you can use a hypothesis test in order to analyze your data. And in this case, you will use t-test for independent samples. In short, hypothesis is what you want to test, And in order to do this, you need an appropriate hypothesis test and you need, of course, your data. When do you need a hypothesis test? You will need a hypothesis test whenever you want to prove or say something about the population with a sample. So you have a population you want to examine. For example, all employed men and women in the Philippines. Since it is not possible to ask all working men and women in the Philippines about their salary, you will draw a sample from the population, and with the help of hypothesis test, the sample will infer the whole population. So the goal of hypothesis test is to test the hypothesis about the population based on sample characteristics. So you have a sample, and with the help of sample and appropriate hypothesis test, you want to test this statement about the population. For example, whether there is a difference in salary of men and women. But before you calculate a hypothesis test, you have to make sure that your hypothesis is formulated correctly. When you want to formulate a hypothesis, there are always two hypotheses that assert the opposite. These two hypotheses are called null and alternative hypothesis. The null and the alternative hypothesis always claim exactly the opposite. Usually, a null hypothesis assumes that there is no difference between two groups. So in our example, the null hypothesis is the salary of men and women does not differ in Philippines. And the alternative hypothesis, on the other hand, assumes that there is a difference between two groups. So in our example, the salary of men and women differs in Philippines. Furthermore, there are certain types of hypotheses, and in order to formulate your hypothesis and to find a right test, you need to know these types. Generally, we distinguish between difference and correlation hypotheses as well as directed and undirected hypotheses. So for example, the difference and correlation hypotheses are: is there a difference between groups, or is there a correlation between variables? And if we have directed and undirected hypotheses, we can ask questions: is there a difference or a correlation? Or is there a difference or correlation in a certain direction when you have a directed hypothesis? So let's take a look now at difference and correlation hypothesis. Difference hypothesis checks if there is a difference between two or more groups. So in our example, we have a group of men and group of women, and we want to investigate if men earns more than women. Or for example, smokers have higher risk of heart attack than non-smokers. So we always want to look for difference between two groups. In order to formulate a difference hypothesis, we need a categorical variable. For example, the gender, we have male and female. The smoking status, we have smoker or non-smoker. And at least ordinal scale variable. For example, the salary of or percent risk of heart attack. Correlation hypothesis, on the other hand, examines relationship or correlation between at least two variables. So for example, the bigger a person is, the heavier he or she is, which is the correlation between the body height and weight of a person. Or the more horsepower a car has, the higher the consumption. So in forming correlation hypothesis, it often follows the form: the more, then the higher or the lower. Now let's take a look at directed and undirected hypothesis. What is undirected hypothesis? Undirected hypothesis wants to check if there is a correlation or a difference no matter in which direction the correlation or the difference goes. So for example, there is a difference between the salary of men and women. Or in another example, there is a relationship between the height and weight of people. So in here, it did not specify the direction of correlation or difference. That's why it is called undirected hypothesis. If we now look at directed hypothesis, we can say that Directed hypotheses additionally indicate the direction of the correlation or difference. So for example, men get a higher salary than women, and the more horsepower a car has, the higher the consumption. When talking about hypothesis tests, it is very important to also look at probability of error. The probability of error is important because hypothesis tests can only determine with probability of error whether a hypothesis is accepted or rejected. Let's look at examples. We have two samples, the sample 1 and sample 2. They differ from each other. So based on each sample, we get slightly different statements about the population. In the worst case, we draw a sample that is very different from the population, and this may cause us to make an incorrect statement about the population. Let's now look at p-value. What is p-value? P-value is the probability of the observed result plus even more extreme result, assuming that null hypothesis is true. So this means that in a population, we have women and men, and there is no salary difference. In our example, let's say there is a difference between salaries of men and women by 2,500 pesos. So our assumption is in the population, there is no difference in salary. And what does the p-value tells us? The p-value tells us how likely it is to draw a sample in which the salary of men and women differs by more than 2,500 pesos. The very important aspect in hypothesis test is the significance level. The significance level is always determined before the examination and may not be changed in order to obtain the desired statement, usually set at 5% or 1% in order to ensure comparability. If we have a significance level or what we call the alpha level of less than or equal 1%, we call it a highly significant result. If we have an alpha level of less than or equal 5%, we say that the result is significant. And if our alpha level is higher than 5%, then the result is not significant. So let's take a look at the result of hypothesis test. So the question is, what would we do with the null hypothesis? Should we retain it or reject it? So first, we set a significance level, then we calculate a p-value, and then we ask a question, is the p-value greater than the specified significance level? If it is greater than the significance level, we keep our null hypothesis. If it is not greater than the significance level, then we will reject the null hypothesis. There are certain types of errors in hypothesis testing. Due to the sample selection, it may happen by chance that the alternative hypothesis is confirmed, although there is no difference in reality. So, null hypothesis is valid. Conversely, the result of hypothesis test can also be that there is no difference in a sample, but in reality, alternative hypothesis is valid. So we have an alpha error or type 1 error, which says that if the alternative hypothesis is accepted, although the null hypothesis holds. And we also have a beta error or the type 2 error. This is when the null hypothesis is retained, although an alternative hypothesis holds. And that would be all. Thank you for listening. So good afternoon, everyone.
Okay, so thank you very much for your well comprehensive discussions. No, again, as I mentioned, you may have also heard no the term null hypothesis, altered hypothesis, or H0 thrown around. No, at a simple level, the null hypothesis is the counter proposal to the original hypothesis. So, if the hypothesis predict that there is a relationship between two variables, no, uh, the null hypothesis would predict that there is no relationship between those variables. So at a more technical level, the null hypothesis process that no statistical significance exists, no, in a set of given observation and that any differences are due to chance alone. Okay? So I think that's it for this topic. So most commonly naman 1 to 2 ang ina-advise sa master's degree Pag mga 3, 4 na sa mga doctorate degree na 'yon. Okay?